Hi everyone, I'm Shanglyu Deng, and I'm a fourth-year student at the University of Maryland. I'm happy to be here to present my paper titled Speculation in Procurement Auctions. So, how do I? This one? Okay. So if a procurement auction is to take place, then a speculator has the incentive to make use of this opportunity. The speculator can acquire the items for sale before the auction takes place. And by doing so, the speculator can reduce competition in the procurement auction. And this is going to raise the payment to the speculator in the procurement auction. So the payment may be high enough, and that may be enough to cover the acquisition costs. Okay, good. To put this into context, no, it's not. Okay, cool. Sorry about the technical difficulties. To put this into context, let's think about the FCC's broadcast incentive auction. So in this auction, there is a reverse auction stage, and TV stations they bid to sell their licenses to wireless service providers. In this auction, we can see that before this auction takes place, we can see that some private equity firms, they actually acquired a lot of TV stations before the auction, and they tried to engage in supply reduction in the auction so that they can get a high price for the items they actually sold. So for example, if we look at OTA broadcasting's operations in the Pittsburgh area, we can see that OTA actually acquired a lot of stations, 11 stations at a price of just about 7 million. And in the auction, OTA bid really high for these stations. These are the bids by OTA for those stations. This is not because OTA really likes those stations. This is simply because OTA are doing something like strategic supply reduction, because after the auction, OTA actually sold the stations unsold in the auction at a very low price. So these stations are unsold. These 5 stations are unsold in the broadcast incentive auction, but after the auction, OTA sold these stations at a total price of 0.275 million, as compared with the dropout price of $264 million. And for the station that is actually sold in the auction, the price is really high. The price for this single station is higher than the total price for 11 stations. So OTA made at least $10 million from operating in this market. And nationwide, because they can operate nationwide, speculation leads to a profit about $400 million. So a natural question is that when is speculation profitable, and how does the profitability depend on the auction mechanism? To study this issue and also welfare implications of speculation scheme, I'm going to consider a speculator and also a pre-auction acquisition stage in otherwise standard procurement setting. So to just capture the economic insights within a reasonably parsimonious setting, I'm going to consider a single object auction. And I'm going to study both the second price auction and the first price auction because they are prevalent in practice. For this talk, I'm going to focus mostly on second price auctions. So now let's jump to the model. As I mentioned, the model is a standard IPV procurement setting, but what's new is that I'm going to consider a risk-neutral speculator who is like an outsider who has no item for sale and no value for the item. The speculator simply seeks to extract some surplus from the auction that is to take place. Okay. The timing is that first the auction mechanism is announced, and also the auctioneer announces the reserve price R. This is common knowledge. And then we enter this acquisition stage, where the speculator can make a take it or leave it offer to every seller at the price P. All of the sellers have to decide whether to take this acquisition offer or to go to the or to reject this offer and participate in the auction. And then we go to the auction stage, where if the speculator acquired at least one item, the speculator has the ability to participate in the auction. And he competes against all of the sellers who actually rejected the speculator's offer. At the beginning of this auction, the number of bidders and whether the speculator participates are become public information. After the auction, as I mentioned, the speculator has no private value for the item, so he derives a value of 0 from any surplus item that he holds after the auction. To fix ideas, let's consider this example where we have two potential sellers. Seller 1's value is 2, and the seller 2's value is 3. And the reserve price is 10, and the speculator offers a price of 4 to both of the sellers. So if both sellers reject the speculator's offer, then nothing happens. They just go to the auction and bid against each other. The speculator gets 0. And if seller 1 and seller 2 both accept the acquisition offer, this is where things become interesting. And now seller 1 gets $4 in payment, but he gives up his items, so there is a loss of $2. So the net payoff to seller 1 is 2, and the net payoff to seller 2 is 1. And the speculator can participate in the auction unopposed because he has all the items in the market. So he can simply claim the reserve price, which means that he can make a profit. He can get the price, reserve price of 10, and he pays 2 times $4. So it means that the profit of the speculator is $2. And of course, if things can go bad for the speculator as well, so seller 1 can accept and seller 2 can reject. In this case, seller 1 exits the game with the payoff of 2, and the seller 2 and the speculator goes into the auction and they compete against each other. So if we think about a second price auction, the seller 2 bids 3, and the speculator bids 0. The speculator is going to get a payment of 3, but the speculator actually paid $4 for seller 1's items, so there is a $1 loss. Okay, so that's hopefully you are familiar with the model now. We can go ahead and characterize the equilibrium of this model. I'm going to first fix the price offered by the speculator and consider the equilibrium characterization. Afterwards, I'm going to go backward and think about the speculator's problem of choosing an optimal price. And I'm going to focus on the dominant strategy equilibrium in the second price auction subgame, which means that the sellers are going to bid truthfully because there is no continuation after the auction. And the speculator, he's not going to compete with himself, so the speculator will simply bid 0 for one of his items and withholding all of the rest from the auction, which means that the speculator is going to win for sure in the second price auction if he successfully acquired at least one item. So actually, we can show that there exists a critical cutoff, and below which the sellers are willing to take the speculator's offer. But if the value of the seller is too high, the seller is not going to be willing to take the acquisition offer. This is because if you recall from this standard result from mechanism design, the interim payoff to a bidder in any mechanism is simply, the derivative is simply the winning probability of this bidder. So basically, if the seller decides to reject the offer and participate in the auction, his interim payoff changes along with his value in a manner that is kind of flat because the slope cannot be below -1 because his winning probability is below 1. However, if the seller accepts the acquisition offer, the payoff to the seller is going to be exactly P minus VI. So in this way, there is a steeper curve, and which means these two curves cross only once, which means that sellers who have low values tend to accept the speculation offer, and sellers who have high values tend to reject. So with the help of this lemma, we can establish the equilibrium and find out the critical cutoff for a given price using this indifference equation here. The left-hand side is the payoff to the seller if he chooses to accept the acquisition offer, and the right-hand side is the payoff to the marginal seller if the seller actually goes into the auction. So essentially, there is a one-to-one relationship between the price offered and the critical cutoff. And now we can think about the speculator's problem of maximizing profit by choosing an optimal price to offer. Now, the speculator's expected profit actually consists of 3 parts. First, the speculator actually gains from competition reduction, but because the speculator has to overcompensate the sellers, the speculator incurs a loss. Also, there is a loss of private value destruction because the speculator does not really value the item. So if the speculator ends up holding more than 1 items, he has to waste the rest of them. Now, this decomposition is clear in the two-seller case. So this first term actually captures the gain from competition reduction, and the second term captures loss from overcompensating the sellers. Finally, the loss from destroying private values is given by the third term. So what we can show is that when we take this critical cutoff to 0, this first term actually dominates the 2 other terms, which means that the speculator can always secure a positive expected payment as long as he offers a price that is near 0, which induces a cutoff that is near 0. Okay. This is going to carry over to the general case. So we can see that as long as the cutoff level approaches 0, the speculator's profit is going to be exactly the gain from competition reduction when there are 2 sellers who accept the acquisition offer. Okay. By this, from this analysis, we can get this proposition: the speculator can always make a positive profit in the second price auction speculation gain. And because there is a private value destruction, we know that speculation is going to result in inefficiency, and sellers are better off with speculation. The auctioneer is worse off with speculation. So now we can also analyze speculation in first price auctions, and analysis is going to be more involved because the first auction subgame is going to be asymmetric. So we have asymmetric bidders. So the equilibrium characterization is complicated, and I don't have all the time to. So I'm just going to skip the characterization part. What I want to highlight is that in first price auctions, unlike in second price auctions, speculation can actually be unprofitable. So if we take this parameterized example, we can see that when the reserve price is low, and when the market is kind of competitive in the sense that sellers are very likely to draw low values for their items, speculation is going to be unprofitable in first price auctions. So if we compare these two auction formats, we can conclude that speculation is always more profitable in second price auctions than in first price auctions. This is because the difference in strategic responses in by the sellers in the two auction subgames. In second price auctions, sellers do not actually respond to the presence of a strong bidder, the speculator, but in first price auctions, they bid more aggressively than the case if the speculator were not present. So that aggressive bidding by the sellers actually undermines the speculator's effort in competition reduction, and that makes speculation less profitable in first price auction. Just to conclude, speculation by accumulating market power beforehand and reducing competition in the auction tends to be successful in second price auctions, but not so much in first price auctions. This is because sellers respond differently to the speculator in the two mechanisms, and speculation tends to harm efficiency in terms in the form of private value destruction. Okay, thank you.
Thank you very much. So do we have some questions? Yep, go ahead.
What if instead of throwing away the items that are not sold, they could be sold back to the same sellers with some kind of option?
Yeah, good question. I actually have an extension where I think about a more involved speculation scheme. So the point here is that a simple speculation scheme can be profitable in second price auctions, but I have an extension in the paper to think about this kind of speculation scheme where beforehand the speculator uses take it or leave it offer, and afterwards he uses an auction to sell back the items he has in surplus. So this is going to be, obviously this is going to be more profitable to the speculator than the simple scheme.
Okay, if there are no more questions, then we continue with the talk by Simon and then